Hello my scholars, this is my school YouTube channel and my name is Frank. In today's video, we shall be tackling JAMB CBT physics past question for the year 2024. So please do not go anywhere, relax, and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we shall be answering question 101 to 125. So let's begin with question 101. Bifocal lens is used to correct the eye defect of. So all the options provided there are all examples of eye defect. Okay, so option A, astigmatism. So astigmatism is corrected with cylindrical lens and not bifocal lens. So B, hypermetropia, also known as long-sightedness, is corrected with convex lens and not bifocal lens. Okay, option C, myopia, also known as short-sightedness, is corrected with concave lens, okay, and not bifocal lens. While option D, presbyopia, is corrected using bifocal lens. Now remember that this eye condition is related to aging, where the eye lens loses the ability to focus on close objects. Okay, so bifocal lens actually provides two different optical power to assist with both near and distant vision. Okay, so the answer to this question is option D, presbyopia. Question 102. A force of 10 Newton extends a spring of natural length 1 meter by 0.02 meter. Calculate the length of the spring when the applied force is 40 Newton. So let's move over to the board to provide answer to this question. Okay, remember that F is equals to KE. Okay, where E stands for extension and F stands for force. So we can make K the subject of formula by dividing both sides by E. Okay, so that K is equals to F over E. Right? So in this case, we can also write F, then we call this F1, E1 to be equals to F2 all over E2. So this will enable us to calculate for the new extension. Okay, so let's impute the values that are given to us. So F1 is 10 all over, E1 is 0.02, and this is equals to 40 all over E2. Okay, which we don't know. So we'll just make E2 the subject of formula. So E2 will be equals to 0.02 times 40 divided by 10. So 0 will cancel out 0. So that will be having 0.02 times 4. And that will be equals to 0.08 meters. Okay. So this is the value of the extension when a force of 40 Newton was applied to it. So we are asked to calculate for the new length. Now remember that the original length was 1 meter, okay, when a force of 10 Newton was applied to it. Okay, so the new length now will now be equals to the original length then plus the extension 0.08 meters. So if we add these two together, we'll be having 1.08 meters. Okay, so the new length is equals to 1.08 meters. So let's return back to the screen to pick the correct answer to this question, and that is option C, 1.08 meter. Question 103. Infrared thermometers work by detecting the A, radiation from the body and converting it to temperature, B, conduction of heat from the body, C, convective air pulse from the body, and D, absorption of heat by the body. So the answer to this question is option A, radiation from the body and converting it to temperature. Okay, so infrared thermometer actually works by detecting radiation emitted by a body and then converting this radiation into temperature reading. Okay, so that makes option A the correct answer to this question. Question 104. The efficiency of a cell with internal resistance of 2 ohms supply current to a 6 ohms resistor is, so let's move over to the board to provide answer to this question. So efficiency of a cell is equals to external resistor divided by external resistor plus internal resistor times 100. Okay, so we just substitute the value because the value of the internal resistor is 2 and the value of the external resistor is 6. So here we'll be having 6 over 6 plus 2 times 100. okay, over 1, and this will be equals to 6 all over 8 times 100 over 1. Okay, 4 here is 2, then 4 here is 25. Okay, 2 here is 1, 2 here is 3. So 3 times 25, that will be equals to 75%. So let's return back to the screen to pick the correct answer to this question, and that is option D, 75%. Question 105. Which of the following measuring instruments operates based on the heating effect of electric current? So A, we have moving iron ammeter, B, we have hot wire ammeter, C, we have galvanometer, and D, we have electric heater. So let's start with option A. So moving iron ammeter operates based on the magnetic effect of current. Okay, while option B, we have hot wire ammeter. So hot wire ammeter operates based on the heating effect of electric current. So that makes option B the correct answer to this question. While option C, galvanometer, also operates based on the magnetic effect of current. Okay, while option D, electric heater, also operates based on the heating effect of current. Okay, but the reason why option B is the correct answer to this question is because electric heater is not a measuring instrument. Okay, and another reason why option B is the correct answer to this question is because the hot wire ammeter measures current directly, okay, by measuring the heating effect of the current passing the wire. Okay, and this causes the wire to expand and causes the pointer to move, indicating the amount of current in the device being measured. Okay, so that makes option B the correct answer to this question. Question 106. What is the color of red rose under a blue light? A, green, B, blue, C, yellow, and D, black. So the answer to this question is black. Okay, so the red rose would absorb the blue light, producing a black color or the black appearance of the flower. Okay, so that makes option D the correct answer to this question. Question 107. Calculate the value of electric field intensity due to a charge of 4 microcoulomb if the force due to the charge is 8 Newton. So let's move over to the board to provide answer to this question. Now remember that electric field intensity E is equals to force all over quantity of charge. Okay, so but remember that we are giving charge to be equals to 4 microcoulomb. Okay, which is also equal to 4 times 10 raised to power minus 6 coulomb, right? So we just substitute our values here. So here we'll be having 8 all over 4 times 10 raised to power minus 6. Okay, so 4 here will be 1 and 4 here will be 2. Okay, so here we'll be having 2 times 10 raised to power 0 minus 6. Okay, because 2 is still the same as 10 raised to power 0, right? So our answer becomes 2 times 10 raised to power 6 Newton per coulomb. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 2.0 times 10 raised to power 6 Newton per coulomb. Question 108. An accumulator is 90% efficient if it gives out 2,700 joule of energy while discharging. How much energy does it take in? So let's move over to this board to provide answer to this question. So remember that efficiency E is equals to output energy all over input energy times 100. Okay, so in this case we are given output energy and we are asked to look for input energy. So it's just for us to switch, just to cross multiply. Okay, so if we cross multiply, we're having input energy to be equal to output energy divided by efficiency. But remember that the value of efficiency is 90%. Okay, it's 90%, and 90% is the same thing as say 90 over 100. So we are going to bring it here. So our output energy is 2,700, then divided by 90 all over 100. So automatically this 100 is going to move up. Okay, so that will be having 2700 times 100 divided by 90. So 0 will take out 0. Then 9 here is 1 and 9 here is 3. So at the end of the day, we are now having 300 times 10, and that is equals to 3000 joules. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option B, 3000 joules. Question 109. Two capacitors of 0.0003 microfarad and 0.0006 microfarad are connected in series. Find their combined capacitance. So let's move over to the board to provide answer to this question. So to calculate for the combined capacitance of capacitors in series, it's just the same way you will calculate for the combined resistance of resistors in parallel. Okay, so here we'll be having 1 over CT, where CT here represents the combined capacitance. That will be equals to 1 over C1 plus 1 over C2. Okay, so we can take any of them as our C1 and our C2. So here we'll be having 1 over CT is equals to 1 over 0.0003 plus 1 over 0.0006. Okay, so we just take the LCM of the denominator, which in this case is 0.006. So 0.0006. So 0.003 into 0.006, that will be equals to 0.0002. Then plus 0.006 divided by itself, that will be equals to 0.0001. So times 1 here, we'll be having 0.0001. So if we add these two together, we'll be having 0.0003 all over 0.0006. Okay, but remember that we are looking for the combined capacitance. So in that case, our CT will be equals to 0.0006 divided by 0.0003. Okay, and this will be equals to 0.0002 microfarad. Okay, so the value of the combined capacitance is equals to 0.0002 microfarad. So let's return back to the screen to pick the correct answer to this question, and that is option B, 0.0002 microfarad. Do you know that you can take practice question with our JAMB simulated CBT past question? All you need to do is to click on the link in the description below, and that will take you to Myschool website. There you will need to download Myschool mobile app for your Android devices and Myschool software for your laptops and computers. Please go ahead and start practicing. Moving on to question 110. 2 points on a velocity time graph have coordinates 2 seconds and 5 meters per second and 4 seconds and 15 meters per second. Calculate the mean acceleration. So let's move over to the board to provide answer to this question. Okay, so for us to calculate the mean acceleration, okay, so mean acceleration will be equals to change in velocity all over change in time. Or you can as well draw the velocity time graph, and from there you'll still get the same answer. Okay, so change in velocity will be so this is our V2, while this is our V1. So you'll be having 15 minus 5 all over, this is our T2, 4 minus, while this is T1 minus 2. Okay, so 15 minus 5, that will be equals to 10. Then 4 minus 2, that will be equals to 2. So 10 divided by 2, that will be equals to 5. Okay, so the mean acceleration is equals to 5 meters per second square. So let's return back to the screen to pick the correct answer to this question, and that is option A, 5.0 meters per second square. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly tap on the notification bell to get informed as soon as we release the next videos. Question 111. An Air Force jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? Okay, so in this question, basically what they are asking us to calculate is for us to calculate for distance, right? So if you check very well, we are giving speed in this question and we're also giving time. Okay, but remember that speed is equals to distance over time. So for us to calculate for distance, we just cross multiply. So that distance is equals to speed times time. So in this case, we'll be multiplying 335 by 5. Okay, and if we do that, we'll be having 1675. Okay, so the distance covered by the aircraft 5 seconds later when the gun was fired is 1675 meters. So that makes option B the correct answer to this question. Question 112. In the diagram above, the galvanometer is converted to A, voltmeter, B, ammeter, C, voltammeter, and D, hypsometer. Okay, so if you look at the diagram very well, you will see a shunt resistance connected in parallel to a galvanometer. Okay, and when that is done, it shows that the galvanometer is being converted to an ammeter. Okay, so with this setup, larger currents can be measured, okay, using this setup without any damage to the galvanometer. Okay, so the answer to this question is option B, ammeter. Question 113. The diaphragm in the camera is similar to what part of the eyes? A, cornea, B, lens, C, ciliary muscle, and D, iris. Okay, so the diagram in the camera is similar to the iris. Okay, so that makes option D the correct answer to this question. Okay, so just as the diaphragm controls the amount of light entering the camera, so also the iris controls the amount of light entering the eye by adjusting the size of the pupil. Okay, so that makes option D the correct answer to this question. Question 114. The device for measuring the angle of dip is A, dip circle, B, dip inclination, C, dip variation, and D, dip meter. So the answer to this question is option A, dip circle. So another word for dip circle, or dip circle, is also known as declinometer. Okay, so the declinometer or dip circle contains a magnetic needle that can move freely, enabling it to align with the Earth's magnetic field. So the angle between the needle and the horizontal plane represent the angle of dip. Okay, so that makes option A the correct answer to this question. Question 115. The velocity ratio of an inclined plane at 60 degrees to the horizontal is, so let's move over to the board to provide answer to this question. So the velocity ratio of an inclined plane, VR, is given as 1 over sine theta. Okay, but here our sine theta is equals to 60 degrees. And remember that 60 degrees is one of those special angles. Okay, so 60 degrees or sine 60 degrees is also equals to root 3 all over 2. Okay, so if we substitute here, we'll be having 1 over root 3 all over 2. Of course, these 2 will move up, so that we'll be having 2 divided by root 3. Okay, and this will be approximately equal to 1.155. Okay, so the answer to this question is 1.155. So let's move over to the screen to pick the correct answer to this question, and that is option B, 1.155. Question 116. The bursting of water pipes during very cold weather, when the water in the pipes form ice, could be attributed to A, contraction of pipes when cooled, B, expansion of water on freezing, C, contraction of water on freezing, and D, expansion of ice on melting. Okay, so the answer to this question is option B, expansion of water on freezing. Okay, so the bursting of water pipes during very cold weather occurs because water expands on freezing, and this increases the pressure in the water pipe, which can lead to bursting. Okay, so that makes option B the correct answer to this question. Question 117. One of these is not the use of an electroscope. A, testing the type of charge on a charged body. B, measuring ionization current in air. C, detecting the pressure of charge on a charged body. And D, producing electric charge in a body. So the answer to this question is option B, measuring ionization current in air. So to measure ionization current in air, ionization chamber is often used. Okay, so that makes option B the correct answer to this question. Question 118. As per Faraday's laws of electromagnetic induction, an EMF is induced in a conductor whenever A lies parallel to the magnetic flux, B lies in a magnetic field, C lies outside but close to a magnetic field, and C cuts magnetic flux. So to answer this question is just for us to state Faraday's law of electromagnetic induction. And this law states that the magnitude of the EMF induced in a circuit is proportional to the rate of change with time of the magnetic flux that cuts across the circuit. Okay, so that makes option D the correct answer to this question. As per Faraday's law of electromagnetic induction, the EMF is produced in a conductor whenever the magnetic flux cuts across the circuit. Okay, so that makes option D the correct answer to this question. Question 119. Photometer is used to measure A, kinetic energy of liberated electrons, B, intensity of light, C, frequency of light, and D, wavelength of light. So the answer to this question is option B, intensity of light. So photometers are specifically designed to measure the brightness or intensity of light, and they are commonly used in photography, astronomy, and other scientific applications to ensure proper lighting conditions. Okay, so that makes option B the correct answer to this question. So for option A and option D, a spectrometer are used, while for option C, the method of spectroscopy are used. Okay, but for the purpose of photometer, it is used to measure the intensity of light, and that makes option B the correct answer to this question. Do you have any question to ask? If yes, please click on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our army of solution providers will provide solutions to all your questions within a short period of time. Moving on to question 120. Using the circuit above at resonance. So remember that at resonance, the inductive reactance equals the capacitive reactance, causing the voltage across the capacitor and the inductor to be equal in magnitude but opposite in phase, making option D the correct answer to this question. The voltage in the inductor equals the voltage in the capacitor. Okay, so option D is the correct answer to this question. Do you have better steps or solution to any of these questions? If yes, please go to the comment section below to comment the question number and the solution you wish to share. Question 121. Find the amount of current required to deposit 0.02 kg of metal in a given electrolysis for 120 seconds. Electrochemical equivalent of the metal is equals to 1.3 times 10 raised to power minus 7 kilogram per coulomb. So let's move over to the board to provide answer to this question. Now remember that the mass of substance deposited during electrolysis is given by M is equals to ZIT. Okay, where Z here stands for the electrochemical equivalent of the substance, I stand for current, and T stands for time, while M stands for the mass of the substance. Okay, so but in this question we are asked to calculate for current. So in this case we just make current the subject of formula, so that I will be equals to M divided by ZT. Okay, so we just substitute the values that are given to us. So let's put this in standard form, so that we'll be having 2.0 times 10 raised to power minus 2. Okay, we'll just move 1, 2, right? So you'll be having 2.0 times 10 raised to power minus 2 divided by 1.3 times 10 raised to power minus 7, then times, okay, so let's put this in standard form. So we'll be having 1.2 times 10 raised to power 2. right? So if we multiply these two together, that will be equals to 1.56 times 10 raised to power. So of course, we just apply the law of indices here, so that we'll be having minus 5. Okay, so here we'll be having 2.0 times 10 raised to power minus 2 all over 1.56 times 10 raised to power minus 5. Okay, so 2 divided by 1.56, that will be equals to 1.28 something. Okay, so let's just leave it this way. Then times 10 raised to power, of course, when this moves up, we'll be having 3 here. Okay, so if we are to put this to 2 decimal places, so we'll be having 1.3 times 10 raised to power 3 ampere. Okay, since we are talking about current. So let's move over to the screen to pick the correct answer to this question, and that is option C, 1.3 times 10 raised to power 3 amperes. Question 122. The acceleration of a free fall due to gravity is not a constant everywhere on the Earth's surface because A, mass of the Earth, B, elliptical shape of the Earth, C, variation in the density of the Earth, and D, rotation of the Earth about its axis. So the answer to this question is option B, elliptical shape of the Earth. Now, one thing we must note is that the Earth is not a perfect sphere. Okay, so the Earth is slightly flattened at the poles and bulging at the equator. So this causes the acceleration due to gravity not to be uniform throughout the Earth's surface. Okay, so that makes option B the correct answer to this question. Question 123. An example of a non-rechargeable cell is A, nickel, iron, B, mercury, cadmium, C, dry Leclanché, D, lead acid. So the answer to this question is option C, dry Leclanché. Okay, so dry Leclanché is an example of non-rechargeable cell in all of the different types of cell listed in the options here. Okay, why the rest, option A, option B, option D, they are all rechargeable. Okay, so but for option C, whenever the energy stored in it is depleted, that is the end of the cell. Okay, so the answer to this question is option C. Question 124. The dimension of power is, so let's move over to the board to derive the dimension of power. Okay, remember that power is equals to work all over time. Okay, so but remember that work is equals to force times distance, right? And remember that force is equals to mass times acceleration due to gravity. Okay, so the dimension of mass is m, and the dimension of acceleration due to gravity is LT minus 2 square. Okay, is LT minus 2 raised to power minus 2. Okay, so let's move up and replace this here. So now that we know the dimension of force to be MLT raised to power minus 2, the dimension of x, which is distance, is L. Okay, so let's bring it here. So let's bring everything together. So you'll be having MLT raised to power minus 2L, okay, all over, and the dimension of time is actually T. So if we put everything together here, first of all, let's put the denominator and the numerator together first. So that we'll be having ML squared, then T raised to power minus 2, then over T. So of course, this T is going to move up according to the law of indices. So that we'll be having ML raised to power 2, then T raised to power minus 3. So this gives us the dimension of power. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, ML squared, then T raised to power minus 3. Question 125. A boy standing 408 meters from a wall blew a trumpet and heard the echo 2.4 seconds later. Calculate the speed of the sound. So let's move over to the board to provide answer to this question. Now remember that echo is the sound heard after the source has ceased, right? So to actually calculate this, you use V is equals to 2D all over T. Or you can think of it this way, that the sound actually moved from the source to the wall and then back to the source. Okay, so that makes D to be equals to 2 times 0.04, which is the distance from the boy where the boy blew the trumpet to the wall and then back from the wall to where the boy blew the trumpet. So we can just use this formula. Okay, so V is equals to, so here we're having 2 times 408 then divided by 2.4. Okay, and this will be equals to 340 meter per second. Okay, so let's return back to the screen. Okay, so the correct answer to this question is 340 meter per second. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.